All right, and so like I was saying, this will follow me all the way around the room. It will listen to our conversations. It will do all that. So we are going to start with, Doc, can you get...
Put all your stuff on his computer. Put all your stuff on his.
So we're going to go into the atmosphere. We to on page 369. Yeah. Okay.
Thank 359.
We're 69.
Do what?
369.
369.
Yep. Okay, so we're going to start with a short video over the layers in the atmosphere, just to kind of start us off on what we're going to be doing for lab and why it's important to realize where weather systems start. Oh, yep. Register. You good, Doc? Okay. Ooh, it's finicky. Lag. All right. Good. Oh, sorry, wrong way.
You're welcome in here some days.
Try it now. Go.
Separated by changes in it.
Oh, goodness. I've lost.
Security. Hello, Alan.
Okay. Move the mouse.
Our atmosphere is composed of 78%
Okay.
nitrogen, 21% oxygen, and 1% carbon dioxide. The first layer is called the troposphere. It is the layer in which we live. This is the layer in which weather occurs.
That's in our atmosphere. It's the highest one.
Temperature negative 20 degrees Celsius to 50 degrees Celsius. And as you get higher in the troposphere, the temperatures get lower. At the very top of the troposphere, temperatures drop to around negative 52 degrees Celsius. This begins our next layer called the stratosphere. The ozone layer is found in the stratosphere. The ozone layer protects us from ultraviolet rays given off from the sun. As you get higher in the stratosphere, the temperature actually gets warmer. This is because the ozone layer absorbs ultraviolet rays and warms up the stratosphere. At 50 kilometers above the Earth, we move to the next layer called the mesosphere. The mesosphere gets colder as you go up. In fact, it is the coldest layers and can have temperatures as low as negative 90 degrees Celsius. The mesosphere protects the Earth from space junk because the ice crystals burn up this space junk as it moves through it. It extends to about 80 kilometers high. And finally, you have the thermosphere that is very hot. In fact, it's the hottest layer. First, the of electrically charged atom and is home of the northern and southern lights, and it reflects back rays. So there we go, the four layers of the Earth: the stratosphere, the mesosphere, and the thermosphere. Thanks for watching. Uploads a new math and science video every day. Please subscribe and
Okay. So how Here we go. There. Maybe I have to go backwards out of the...
When did you get there?
Oh, I don't know.
No. Just reopen it, I guess.
Okay.
Driveway.
Okay, while we're doing that, so what does that tell you about our weather systems? Where do they happen? Which layer of the atmosphere?
The
Troposphere, right? So when we talk about the troposphere and all of the things, if you can't pay attention, then you can't do the lab, okay?
I would.
No, I'm not talking just to you, sweetie. So when we talk about that, we're talking about all kinds of weather systems to include winds, rains, tornadoes. All of that happens within the 0 to 50 kilometers from the Earth's surface. And so we want to go up. So why did they say that the temperature drops with altitude only in the troposphere?
Because you're going up in altitude and getting closer to that next layer.
Right. And the next layer was...
The mesosphere? No.
Did you have something to add to the first part too?
Oh, just that once you go up so far that you hit the ozone layer and it reflects a lot of that UV rays.
Exactly.
It's hard.
It's absorbing all of that, right? The IR is being absorbed by the ozone, so it's colder as you get to that level. And then the mesosphere was right above that, right?
The stratosphere and then the mesosphere.
Yes, stratosphere, you are correct. And so what do we do in this stratosphere?
The lower stratosphere is as cold as the
Why do you think they have to fit in our troposphere?
is it It's not the gravity's not as heavy there.
Okay, what was yours?
Because it's easy flat, but it just doesn't know whether it's no thickness.
I like.
Not as much.
Moving. We in our book. There's a different diagram, and they have these moments of pause in between the layers. What do you think that's for?
The line where they're meeting. Well, in between there's like a gap.
It's not so much an empty gap. What do you think happens there?
It's hot.
It's like a transition zone,
Yeah.
right? So there's a little bit of both interaction in that little fine layer, just like
Basically like adapting to it.
right.
Changing
It's an
it to where
adjustment.
It's going to be able to handle that.
Exactly. So think about in a cake. You have layered cake, and sometimes when you put something in between, it can bleed into the next layer.
And
That's exactly what's happening.
Like cakes, you have to, if you're layering them, you have to like cook it, and then you have to put the next layer on, cook it, and the next.
But what if you use like a
Or you
jelly
need to-
substance
yeah.
that's wet, like
It's
these?
gonna like try to soak into it.
It will soak into
So
it.
it's gonna
So there's saturation.
Yeah, so it's gonna. Some of it might stay on top, but most of it's just gonna soak into it.
Right. Okay. So, and then the next level was what?
Above which one?
The mesosphere. And what happens there that's unique?
That's one of the coldest. Well, no,
It's colder, right? It's the coldest layer. And what did they say that was unique?
Space
Yeah.
junk, like,
Space junk.
burned up by the ice crystals and all that up there.
So whenever we're watching those sci-fi movies and they're appending to our atmosphere and then they start getting hot and things start catching fire, what layer are they in? The mesosphere, right. So what does that say in the book about as far as its individual features? If you turn to,
it's on 170.
it is 371. Yep, okay, so it's right here. And it's how many kilometers off? Away from our surface. Okay, and that's what we're talking about. Because why do you think that layer is so cold, and then we transition to the next one? But this you can peer next to you think that to talk to somebody next to you and kind of just some ideas of why you think that is. So what are some of your ideas?
I'm thinking that the thermosphere is heating up through like the atmosphere.
Well, they're all layers of our atmosphere, right?
Yeah.
So they're all part of it.
Like from the previous layer it was really cold.
Mm-hmm.
So the cold air goes down, which means the hot air goes up. So I'm thinking that the hot air would go up towards the thermosphere.
What does it say about it, though?
It's an extremely thin layer.
So if we have sun rays penetrating that, then bouncing off of our ozone, it's getting all the heat, right?
Yeah.
And that's where we see all those pretty lights.
So it's essentially bouncing off the mesosphere layer and then going to the thermospheric layer.
All right, let's get back together. What did y'all talk about? I'm going to hear from the front of the room. Anybody from the front table want to share what y'all talked about?
Maybe it like reflects or I don't know.
It does reflect. What did it say about its consistency in the book? What made it kind of unique compared to the other layers?
It's composed of a lot of different types of gases, and it receives the most solar radiation.
Right. And it also is bouncing off of that mesosphere where our ozone is at. So what does that say about the sun's radiation? Where is it being held?
In the ozone.
Is being held in the thermosphere. Right. And so it's hotter there because of the reflection of the IR, right? It's not being absorbed in there anymore because like here degree days when it's 90 degrees Celsius, and it flies from negative 90 degrees Celsius to 1200. This is also the thinnest. So it doesn't have a whole lot of density, all of that, right? Okay, so let's talk about some things that happen, and that is weather. Here that are unique. So we can see the aurora borealis up there on the very top, and those are a reflection of lights and all that stuff. But that's not really like wind or anything like that. So when we talk about wind systems, weather systems, what are we unique down here? Tornadoes, okay? Huh?
Wind turbines.
Those are driven from wind. So we have wind currents that drive those, right? And so what are systems, though? Like we said, tornadoes. What else can happen? Thunderstorms, hurricanes. All of those are systems that are driven by wind. But why would wind happen here? What is unique about this layer? It's the bottom, right? We're closer to what? Water, okay? So we have interaction between hot and cold, right? And those are driving temperatures. But we also have the most experience with what happens as far as like Earth rotation. So what happens way out here is felt more the closer you are to the center. So as we are rotating and we are on an axis, right? Does anybody remember the axis? 23.5, 24.5? Yep. So not only are we on an axis, okay? So we are essentially sitting like so. Mr. Sunshine over here, he's having a good day. He's happy. We get rays in. What is this line right here in the middle? The axis, right? And that is what we know is like the equator. And so what do we know about the weather? Are like stuff are on the equator because it's wet.
I want to argue.
Up here though. And right. So as we are rotating and revolving, our world is moving that troposphere and wind systems around, right? And that gives us wind patterns, that give us weather patterns. So heat, in particular, happens two ways, or three ways. Radiation, we know. Where did I put that mouse? Anybody see it?
Took it right.
Oh, okay. So it happens 3 ways. We've talked about the Earth's rotation and the radiation that we get from the sun. Okay.
Maybe.
I saw it. Where is it? There it goes.
It's very fast.
It's going. And now we're going to see a little video about how it actually influences what we know as global winds.
Science and global winds. The Earth is not heated evenly. This uneven heating of the Earth produces pressure belts, and these pressure belts occur at about 30 degrees of latitude. The combination of these convection belts and the Coriolis effect, which is the curving of the path of winds in the ocean due to the Earth's rotation, causes global wind patterns. In this video, I'd like to look at the major global winds. Up first are the polar easterlies. They blow from the northeast in the
That's what we talked about right here.
to the southeast in the south. These
This is
belts
actually 90.
extend from the poles to 60 degrees latitude. The polar easterlies are formed as cold sinking air moves from the poles towards 60 degrees north and 60 degrees south latitude. Next are the westerly, and they blow to the west. These wind belts are found between 30 degrees the westerlies towards the poles from the westerlies can carry moist air over the United States, producing rain and snow. Next are the trade winds. They blow to the southeast and the south. Called to the west in the northern hemisphere and to the east in the southern hemisphere. Next, northern hemisphere meet in an area around the equator called the doldrums. In the doldrums there is very little wind because the warm rising air creates an area of low pressure. And finally, the horse latitudes. At about 30 degrees north and 30 degrees south, sinking air creates an area of high pressure. The winds at these locations are weak. These areas are called the horse latitudes. According to legend, this name was given to these areas when sailing ships carried horses from Europe to the Americas. When the ships were stuck in the windless area, horses were sometimes thrown overboard to save drinking water for the sailors. Remember, this is just a legend. Most of the world's deserts are located in the horse latitudes because the sinking air is very dry. So there we go, the major global winds of the world. Thanks for watching, and move.
Oh. Close. Go down. Okay.
Moo map, upload the new map, and
I'm not touching it.
science did deal every day.
So what does that tell us about what kind of weather systems are found because of wind? So where did he say that we have almost no wind? What part of latitude? Do you remember on here? Okay. And so he gave it the fun name of the horse latitudes, right? But because heat, what kind of heat is it getting? It's getting thermal heat, right? That heat and it's nothing to move it. So we have radiation that we've talked about, and we have conduction. When heat or burn, and you have to wear sandals because that is hot, is holding on to that. The molecules and atoms inside the sand, inside the surfaces, are holding on to that heat. And then we talked also about the convection, which is the transfer of heat, right? And we talked about an oven and how it cooks better because it moves it consistently. And so whenever we're talking about the layers and we talk about heat, is we want to really focus on the 3 types. But today we're going to do a lab so that I can demonstrate to you what conduction really is. And to do that, though, we need to first go over a lab safety agreement. And so if you can take this and sign it whenever we go over it. Don't sign it before. I want to make sure that you and I are on the same page. And these are just some of my expectations of how we will conduct ourselves when we are back here. This lab will take a little while as we are going to wait for room temperature water to heat up. Perfect. Does everybody have a safety agreement? Okay. Yeah, we had some that didn't show up today, so that's good. Okay. So general guidelines. Who wants to read off number 1 for me? Okay, go ahead.
Responsibly at all times.
All times, right? So what does that mean?
Like, don't mess around.
Don't mess around. Horse playing. Attention so that we don't get our danger
Or spill
or spill.
harmful chemicals.
So follow and verbal instructions. Right? It's a communication problem. It's not an understanding problem. So if you said, and then I can read. Yes. We have hot plates back there. We have food coloring and glitter. So don't touch them until we understand what's going on, okay? And if you are wearing something that you're afraid to be stained by food coloring, you can volunteer somebody in the group who is not afraid to get food coloring on their hands and or get a protective layer on yourself, okay? So 4 is the big one. No eating or drinking near the lab, okay? I don't need you to ingest glitter or any other substances back there.
Oh, come on. It's not unharmful.
Those beakers have had other substances in them.
I know it's in it. You don't want to drink them.
Yeah, you don't want to drink from them. So please don't drink it or put it near your face. So 5, we'll be going over the lab together. So step by step together, making sure everybody is doing exactly what they're supposed to be doing together. So you don't have to read off anything. Mostly, I just really, really want you to pay attention to what is happening, make some observations about it, and be able to discuss what's happening, because there is an assignment in your classroom that is following this part. Okay?
So basically, everybody's going to have some type of a job for it.
Yes, you should delegate some positions within there. Okay? So, read over the lab instructions before you perform the lab. That will be for me, and I will do that for you. And keep your work area neat and clean. Like I said, you don't have to bring the lab sheets, but if you want to bring a piece of paper and a pencil back there so that you can take some notes on what you're seeing or maybe draw what you're seeing, I would love to see those. Okay, so cover all liquid-filled containers to avoid slips or spills. The fluid that is going to be in there is going to be hot. Try not to put your hand in there other than when I tell you to, okay? So run, shout, or throw things in the lab. That's a given, right? We've done that before.
Did you notice any unsafe conditions in the classroom?
When it's warm up to stick his finger in there, I need to know. Your friend thinks it's cool to put glitter in their hand and blow it on somebody else. I need to know that. We'll have dye.
Yeah, food dye.
And for that, it is drain safe. So you can pour those into the drain and rinse your beakers there and put them on the dried. What about number 13? Yeah. Go ahead.
Keep your hands away from your face while doing lab. Wash your hands after the cleanup is complete.
Exactly. So I understand that it is pure food dye. It may stain your hands. I'm just going to put that out there right now. If you're handling it, it may stain your hands. It will come off, just probably right now. Okay, so, and we've already talked about rinsing out and drying your glassware. Stay at your assigned lab tables. You will go up in the area that you are, so that way I can track attendance. It's nothing against y'all. It helps me. So y'all will be from tables to tables. So there's not intermixing of groups, so I don't get confused when it comes to data. Yes?
Carry sharps appropriately tipped down and away.
Right. We don't have any scissors at the moment, but there are things around the area that Doc has. Try to keep those away from you. If you should happen to have a sharp pencil when you're walking with it, just make sure that the tips are down. So accidents, of course, tell me at any time anything ever happens, right? No matter how minor, I need to know. If your glass breaks, I need to know. It is going to get hot. I can't control if it breaks or not. But if it should, I need to know immediately, okay? I'm sure we all hear it.
Don't walk away. If a beaker breaks on the ground, don't walk. Stop walking so that we can pick up the glass before you step on it, please.
Right. And going into that also, we will be protecting our eyes with goggles. They are on the tables next to your supplies. There are different styles. And if you're wearing back sleeves like I have these, I will need to take this off, okay? You can look over if it's and you're looking at your face, that it will be hot water. Okay, so if you put your printed name, sign, date it, and then turn those. Be at the lab that's going. Yeah, our lab right there.
Can we walk over there?
Once you have signed the agreement, you can, but please do not touch anything. Yes. Please, the only thing you should have is either a piece of paper and a pencil or nothing at all. Okay. So you're at the first closest table. You can put the glasses on if you would like. Okay. Do we have a rubber band? Oh, that's not going to work. I hope it doesn't grab your hair. It shouldn't pinch your hair. Just do it loosely. Look at him. Look at that. He's...
Oh, wait,
Yeah.
how did you have a ponytail?
I don't use it. I just have it on there.
Where do you want us to go? I'm just gonna use
You can go to the far back table. Doc, can you show them that lab right over there in the corner? This table, you will be on the one, the farthest one, back there. You can go ahead and go. And then this table, the one with the huge beaker. Wonderful. Thank you. Thank you. This has a sensor in it and a microphone. So as I'm talking and moving around, you're with the big beaker right there. Thank you. So it follows me around, and then I upload the footage to Swivel, and I can edit it from there. And then as far as like starting and stopping.
All the bad stuff.
No, just the end parts, just like where we're starting and stopping. And then I on a private channel and allow Dr. Staples to view it. She views my interaction with you guys and my ability to be in a classroom and y'all to be educated while I'm here. And once she has reviewed it and stuff, she will give me guidance on what I could have done better. Maybe some points of lacking communication or things that I could have worked on or things that I did really well. Or she can monitor the participation of the students and see who found it interesting and who did not. Yeah. And it helps me, so when I have my own classroom, I have something to refer back to with, okay, so when I did this video, people kind of at this grade level, at this time of day. Right, exactly. So, just going through the...
Put your goggles on.
Someone took my glasses.
Oh, that's not nice.
Yeah, 2 people here. Put your goggles on. Turn on, you don't get to play.
Yep. Do not want you to get hurt. So these are okay, this is okay, this is okay. All right. Okay. So we are going to be simulating 2 different things. Oh, Doc, the icicles. Okay. So we're going to show the interaction between hot and cold air when they meet. And what did we say happens whenever hot and cold air meet? They make a storm. So, while we are going to kind of simulate that happening, but we also want to take into consideration that there are air molecules and water vapor and molecules up in the air moving. So that's what your glitter is. So those are all of your gases that are going to be moving, and then with your winds. So you're going to see the interaction of the glitter as well as the dyes interacting. So the first thing you need to do is take your food coloring with room temperature water, whoever's going to be doing your food dye. Just pick someone. All right, you're going to place your hand in. Bottom. That's great. Let's clean.
How do you make a mess?
Yeah, no water, and that we're not. Make sure it doesn't get tipped off of the side.
Remember somebody saying something about not messing with stuff that was not part of the lab?
Sorry.
Good job, Connor.
They said it spilled water. Mine was fixable in 2 seconds.
Mine's fixable when he was told.
All right.
Let's make sure this thing.
If your die is at the bottom, you can now place however much glitter your heart is contented to do. It shouldn't be in abundance to where you can't see the interaction of... No, I wouldn't say all of it, but a good amount. Definitely enough to get the top layer. What are you comfortable with as far as heat? A full is okay? Okay.
No, we'll do about half. Half is fine.
All right. Are you ready to move on, gentlemen? Yes, we are. Okay. We will wait till everybody's done. Can I get a thumbs up in the air when you're done with your glitter? Can I get a thumbs up from anybody who is done with their glitter and food dye and is ready to move on? All right. At this time, allegate somebody in your group to turn the dial in the front. You should go halfway up.
Halfway, so like 290?
230-ish to 265. Be in between there.
So 3 is too high?
Huh? 300 is a little too high, yeah. We want everybody to have the same interaction. Yeah. This one I'm going to do a little bit higher just because this one's mine and it's the largest beaker. Okay. It'll take more. Okay. Start. Let's. So as it is rising, amongst your table, see what's happening. So it's leaving the troposphere, it's leaving the bottom where weather is happening, it's rising. Wow! Has anything happened to your glitter yet? Not yet. Huh? It's just standing there? We have to wait for it to start moving and conducting.
We had water. It started boiling underneath.
Oh, yeah. Okay.
So hopefully it don't go kablooey. Which will suck right now if we're with this close. Nothing has happened to the glitter yet, though.
No, nothing has happened to the glitter because it's way up there, right? Yep. Okay, so now we have hot or warm air being conducted into our atmosphere, our troposphere. This is where weather is happening. So let's introduce slowly.
So disappointing.
Do we put it in?
Yes, place it inside.
Right to the bottom.
And see what happens to the cold water.
It looks green now.
We need some ice.
Yeah, I'm coming. This one's kind of slushy.
A popsicle.
Hey, man,
Why would you waste that?
I'm not wasting
It's a
it.
waste.
It's science.
It's not meant for science.
You want to put the rest of this one in here?
Sure.
Yeah. Okay, so cold air do? What did you say? What do you say? Or are you trying to eat it? No. Right. Let's wait for it to.
Notice that it made like a ring around it.
Right.
Instead of just like all spreading.
Right. We'll see the
Hey, there's a
interaction
sparkle in the center.
as it's starting to boil. Then the fun starts. No, we don't want to do that. We will wait for it to boil on its own. Doc, you want some popsicle? So what's happening to yours?
It's staying at the bottom.
We saw cold air immediately go to where?
To the top.
To the bottom.
To the bottom, yeah. And hot
Now-
air went to the top.
And it brought down some of your molecules, right?
Yeah.
So it's starting to interact. And yours is starting to interact. So what is happening to some of your glitter?
It's floating up.
Right. What do you think is going to happen when we get a tornado?
It's going to spin.
It's going to spin. So let's wait for it to spin. Ooh, that one's an interesting smell that y'all have on this side.
Yes, it's probably because of the amount of crap that we have thrown in there that shouldn't be in there.
So these are your water molecules, your water vapor, your different gases throughout the system.
Drop this in there.
No. We've got quite a bit. But let's talk about what you think is going to happen when they start to move.
What's theirs?
This one is my control.
Oh, what do you mean? Like when the water starts to boil?
Yeah, so when convection starts to happen and both of them are interacting
Do we
fluidity.
really have to wear glasses? I think
Yes,
we
please
like
put them down.
It's gonna come to a roll. It's gonna constantly shuffle and go down, and then come back up, and then
Exactly. And that was called what?
Lava lamp 2.0.
I think we should amp the temperature.
What kind of
I can't remember for the life of me.
convection?
Oh, okay.
Yeah. Convection that's going to happen. here.
Are you just eating that? You're not eating that. I guess you can't eat during the lab, but still.
You're right.
There you go.
So you should see the dyes interacting with each other too.
I was going to.
You should have.
But then you said not put all of it in.
I didn't say put all of it in. You could.
All of it,
You
but
could have
right.
put most of it in.
Okay.
We're starting to get more current.
Yep.
There was big bubbles on that side.
Yeah, don't touch it. Don't put your finger near there. Just kind of observe and see what's happening.
Can you put more glue in?
Huh?
Can you put more glue in?
You could probably put a little bit more in. Yes, but not too much. It is a plastic and it will melt at some point.
What do you mean? Oh, the glitter?
Yeah.
Plastic?
Yeah.
Oh, like a glass.
No. Yeah. Feeling good. So as our cold, our blue dye on the bottom interact down those different
It looks
gases.
like green at this point.
At this point, yes, because blue
Can I have the
and
rest of
yellow.
that popsicle?
It has a fur on the top, and you're not allowed to eat in the lab.
Can I walk there and eat it?
No.
Can I put another piece of popsicle in?
Can we put another piece of popsicle?
We can put a little bit more as you're starting to warm up. I'm not sure how much y'all got. It's to boil. What do you think is going to happen? Please, no phones at the lab.
Hey,
What's going to happen?
those
Don't touch.
together. I'm not touching.
Right. They're starting to clump together, as gases do.
What's starting to clump together?
The glitter,
Oh, the glitter. It's
right?
all getting concentrated at one spot.
So what observations are we making? So what do you think as effect?
Glitter might go down.
The glitter might go down.
I don't really know.
So the hot and cold are mixing together, and they're causing a current, and those
It's gonna just I don't know. Turn around.
it might be. It's gonna look like a little tornado once it gets warm enough. Oh, okay. How are we doing?
Very good.
Very good. Have we got some bubbling going on yet? A little bit. Oh, yours is doing it. Come here. It's doing it. What's happening? Look up at here. Watch. Do you see that movement?
Mm-hmm.
Do you see that movement right there?
Okay.
We have some samples that have started to actually have the conduction going on. This one in the beginning on the front desk is doing a great job.
There it goes. There's
Yep, there it goes.
some extra things started. Very small.
There we go.
All you had to do is amp
It's melting whatever was on the side of it earlier.
We wanted to make sure
was that
that it was a safe heat.
What's bubbling
Oh,
over?
don't.
What is that?
Something disgusting.
Yeah.
A booger.
Oh, booger.
Yeah, I see you earlier. Sorry. Yours is on 540 right now. That's the max it can go to.
You should put on some glasses.
I can see the glitter on the top.
Oh, there we go. No, table one's got a good view. Starting to, yeah.
Station lab station, please.
Please stay at your lab stations and start making observations. Put your glasses back on, please.
Nothing's happening now.
At least I can't see because it's so dark.
Yeah, this is boring.
Looking at what?
Pretty much.
All that's happening is glitter fall.
Exactly. It's starting to move and start those systems. I'm a little silly out there. Especially observing from the side like this. Up. You didn't want to tan today with a burner. Oh no. I was joking. So what do you think the temperature is inside there now? As to where we started?
Pretty warm.
It's pretty warm, right? So what is the difference between what we put in versus what it was? So room temperature water. I let it sit for about an hour and a half, so it should have been room temperature, so it's what, 65 to 70 degrees. We've heated it, but we put cold on top of it, right? Are you starting to see your currents?
Hey, can we just fry it instead? He turned our heat up.
Oh yeah.
We got a little mountain underneath.
Yeah, we need to get some bubbling action.
Yeah, he turned it up.
Oh, there we go. See? Right there. Oh, look through the glass. Do you see the waves? It's not, but do you see the hot and cold interacting right there?
This is no longer room temperature at all.
No. So
It's 200 degrees.
right.
Yeah. He's doing that.
Yes, we are. We are turning it up to full.
Yeah, I'm trying to do that job did.
I know.
He turned it all the way up.
I know. So we're just gonna watch it happen faster.
It's still slow.
Okay, do you see the waves?
No.
Okay, look through the glass. Do you see the waves happening?
I think the bubble going up.
No?
I just see that bubble.
You should see it, especially from like where well, we have between hot and cold. Does take a
These goggles are making my makeup. Okay. I thought I looked ugly.
When I was in high school, we used to wear like halfway button up shirts with collars like that one. And we would call them nerd boys. And a band named Weezer made it really popular. And we would...
You gotta kick Doc out of lab. He touched the water.
Oh no, Doc!
Garrett.
He has had a safety violation on Doc because he stuck his finger in the water.
You never made him sign it.
I didn't make him sign it, you're right.
Don't let him stick his finger in that one.
Yeah. Here we go. That's a lovely smell, right? That's not harmful for anybody. Facial.
Right before lunch, it keeps them from being too hot.
I think that's too hot.
I think that is the substances that were on the beaker before I put the stuff in there actually burning off.
And what is the stuff on the hot plate?
That is a mystery to you and I and everyone in this room.
Hey, guys, you're spilling glitter. This is really...
Let's move it all the way up. Oh, look at this. Yeah, and we're going to watch how the molecules in the air interact whenever it's hot and cold. Come look over here and show me what you see. Tell me what you see. Through the bubbles. What do you see? Do you see the waves?
Yeah.
Do you see the waves?
Yeah, we were looking at them earlier.
Yeah.
A storm is a brewing. That it was staying on top. What does that say? It is rises because it is less or more dense? Less dense. So low pressure, right? Drier, colder.
Yeah.
Right? So when I say a cold front is coming, do you expect high or low pressure? Low.
So I saw a red sky this morning. And I thought of you.
Yeah?
Yeah. Red sky in morning, sailors take warning. So I was like,
And that has to do with the water molecules in the air. It's bouncing off, meaning that a cold front is coming. All those crystallized water molecules in the air are being reflected in the morning, which means it's going to be cooler that day than it was the day
well,
before.
it's actually supposed to be warmer today, but there is a
Right,
cold front
it's
with
coming.
rain.
It's coming. Yeah, so if you're moving anything or doing anything outside, get it done now. Here we go.
Hey guys.
Hi, going. Nerd chic. Nerd chic. Breadsticks. That is something burning on there.
Yeah.
Is that glitter on there? Did you put glitter on the...
No, this was there before.
Oh, I see some bubbles on the surface.
Oh, yeah, that's
Yeah.
like a dark black at this point. Look at the loogie over here.
The booger?
Boiling here in a second.
Kentucky Fried Glitter.
Yeah, their bubbles on the surface are popping. It's boiling.
Oh, yeah. Look at those currents going. You see them?
Welcome to Kentucky Fried Chicken. Coming up.
Kentucky Fried Water. Yeah, that makes sense.
Oh yeah,
I don't know.
going.
There she goes. Look at those
Would this
currents.
have gone fatter faster if we used like a metal cup or something like that?
Definitely. However, how would you have seen the interaction of the wave currents on the side?
wouldn't. You can look from the top. I don't know.
Are you supposed to look inside a hot surface?
No.
No.
But
That's why we have glasses.
That's why we have glasses. Oh. I think something's on this hot plate that is... There we go. What's happening to your water molecules?
It's all getting stuff.
now it's turning pink.
Everything's mixing together, right?
Yep.
We have a lot of movement going around.
Would you be against me putting more food coloring in?
It's pretty. Really. Observe what they do and then turn it down. There we go.
Whoa! It's kind of like spinning.
Yep.
Turn my head.
So we have precipitation building because of the hot and the cold currents mixing. The water molecules and all of the different gases are interacting with each other. And what did we build?
Yeah, that side like has no glitter and over here has more. Is it just like
That's the, yeah, it's the hot plate. It's the hot plate.
But there's no cold in there.
Not anymore, no.
But I thought we were gonna get sister.
It should be moving it. You can see the glitter moving on theirs.
Look at other
If you don't touch,
Okay.
and somebody needs to monitor yours and take turns. So just so no one bumps into yours. There we go. Huh? This is your last time. I'm telling you, get your phone. Okay. Well, you shouldn't have anything other than what's here. Thank you. Because we've turned on the heat. Right.
We have like
You see the convection?
I know, but we have like a little black deal down here on the bottom that jumps around.
That's where all the rest of the glitter is. It's just hard to see.
Unless you have a straight up stream.
Well, it's doing a roll
On top. Beautiful. Look at your storm.
Feel the bubbles pop off the table.
Do you mind if I take a picture of you?
I will not accept this.
Yes, you can.
Picture though.
Take it.
There we go. Good job.
Yeah, good.
Was ours good?
Can I get on one side and a thumbs up? I'm going to insert. No, not on the. Put your glass. Okay.
You've already recorded me the whole class.
Yes. Awesome. Thank you.
Yeah, ours is better, Cade. Deal with it.
Well, it's
ours is-
actively moving in the
ours is
colors that
15
you.
years.
Yeah. Let's take. All right, guys. Let me see a picture of you guys with y'all's tornadoes. Come on over here. Let me get a picture of you guys. That's what's happening. You're just gonna lean in and be cool guy. There we go. You want to get in? No, you're good? Okay. Oh, no smiles allowed. Woo! Learning in progress. If you have yours out of boiling, go ahead and start turning them off. We'll wait for them to cool down. And then, oh my goodness gracious. I care about what you look like too. I wouldn't let you look weird. All right. Thank you. Let's see. May I take a picture? Well, don't put your face on top of it. That's one of the rules that you signed. Say cheese.
Cheese.
I'm not gonna lie. Right?
Is the glitter supposed to stink?
Yep, it's convecting. It's going around. It's going to be pushed around. See how it's moving throughout?
It's gonna go down and then come
Exactly.
back up. Oh.
convection. It's going to keep on circling. So not only does that happen on the outside in our troposphere with the winds and the rotation of the Earth, but it also happens internally, and that's how we get molten lava. The atmosphere.
All over here, and you can start seeing it, big chunks over here.
Yeah. We are massaged by our gravitational pull to the sun, so we're constantly moving. The inside of our core is being massaged, and it's fluid.
Make sure it's
No, we're and assignment that I'm not sure. We get out of here at 11:25? 25? 35? 25. 25. So, if you can pull up the assignment for me.
I cannot, you know.
It will be in your classroom, your Google Classroom. It should say Miss Roche's Convection Lab Experiment. And you have the rest of the class period to work on that. You can work in your same lab tables groups as long as the conversation is geared towards finishing y'all's assignment. While you can work together, I need individual work, please, turned in. So work as a team, that's fine, but each person needs to turn in their own assignment. It should be able to open to, yeah. You should be able to open it to Word, right?
No, it's not.
Is it? Huh?
How do we,
Doc, how do they get and adjust it? How do they adjust the document? Make a copy. There we go. What's that?
I kind of hope it like blows up or something.
Come on, man. Don't wish that on me.
Not on you, but like, you gotta have some excitement.
This is exciting. Every day in science is exciting. Did you have fun, Doc? Conversation should be on the last. For the draw, you can just draw me like what you saw.
How do we draw something?
Draw to conclusion.
How do we draw something?
I don't know. This is the form that they had for me to do. Can you insert something?
Probably.
Or describe what was happening?
Boiling water.
Yep.
With glitter.
There you go.
So did we just start at question 1 and answer from there?
Yes, please.
Okay.
Alright, you want me to just put that in there?
Sure.
Hit you really hard, Devin.
You can put that in there. That's fine. Or you can look up a confection.
I really want a hot plate. I could just make like grilled cheeses in my room. Because I have a fridge in my room, so I could just keep the cheese in there.
Your mother and your father would never see you again.
Nope.
She's like, actually, no. You can start at 1. I don't need a picture. We talked about it in discussion. Can you open up your laptop for me?
Google Classroom.
Google Classroom. Copy it into a Word document or Google Docs. Doc, where would you like the administrator teacher glasses at? Where would you like these? Okay. Yeah, you can start on 1 for time. Yes.
Wait, we have to repeat our experiment. What if we don't know?
Okay. Just explain it to me like if you were to tell someone else how to conduct this experiment, what would you tell them?
Who's doing like doctors?
The 3 convection we talked about. And you can use your book. Miss Roche? Yes. Number 3, you can use internet resources. Where
Higher down, lowers up. Or opposite, flip them.
we talked about low pressure systems along the latitudes.
Hardly any movement.
Hardly any movement, lots of sun radiation, can't really move it around, so its low pressure systems are hot. High pressure systems are dense, right? Do they settle on the bottom?
No.
And that's what happened, right? And then it moved up.
Is your last name like Italian?
It is, from what my husband has let me know, is French. It means rock, which is super fitting since I'm going to be a geologist. Yeah.
Oh, you're not already a geologist?
Not yet. I have not taken my certification yet.
When do you take your certification?
Probably when I graduate in December.
Can I call you Mr. Rock?
Miss R.
Can I call you the Rock?
Miss R. Yeah.
Can I call you the Rock?
The Rock? No.
Dwayne.
But I might take on that nickname.
Please name like
I cannot have any more children.
Yeah.
You name one of your children Dwayne?
No. Archer, Merrick, and Vivian.
Dwayne the Rock.
His middle name.
It's Archer, Jace, Merrick, Scott, Edward, and Vivian Grace. And I didn't even know until my son was like 2 that I actually rhymed their name, Archer, Jace, and Vivian Grace. I had said it both out loud to somebody as I was introducing them, and I was like, oh man, I did not realize they rhymed. I was like, wow, I obviously like the way that ends. We got about 10 more minutes for you to finish those documents for me, please. You are allowed to use your book, your lab partners, and internet resources. And when you're describing, tell them to repeat it. Class information, please.
All right, we just turn this in at 5.
Mm-hmm. Did one of you ladies leave your pencil at the table?
That's probably mine.
Okay.
So I'll just take it.
Good job. All right. Oh, don't touch. Oh, Doc, you scared me. He's a brave soul, fighting in the outlands of Kansas. Rides a noble steed with Doc Sylvester on the back. Teaching kids science wherever he goes. Trying. You do a wonderful job.
You're doing fine too.
Thank you.
That's better today.
Yeah. And I think time management worked out great because now they have like 5 minutes left to be able to turn it in and they can go. All right, we got about 5 more minutes, guys. Thank you so much for your participation. Precipitation. Go away, go away. So what did y'all think about the Adobe Spark page that rolled instead of like an actual PowerPoint?
I like it.
Yeah. That's actually an app that y'all can use on y'all's Apple devices too. Adobe Page. Yeah, and you can add personal pictures and have it like as an entire background. It's one of the teaching tools that we try and share. And you can also make videos for like your friends or graduation or something like that if you're going to do like a montage video or record.
What were some of the 3 questions again?
The what?
The wind currents.
The trends, the westerlies, and the coordinates effect. Yeah. You used me to get the answer. Because I realized what you were doing. I gotta be here.
Now I know.
Yeah.
So technically I do know the answer.
Yes. Okay. What direction do the
West.
you go? If you have turned everything in, feel free to close up your books, put them together on the corners, turn in your assignment, put up your computers, and get ready to go.
Yeah, his won't load.
Oh, perfect. Perfect.